Hello guys, we're going to correct the homework and then we will continue the chapter. Homework correction number 1. I have a battery connected to two resistors in series and I need to find the main voltage UPN given that R1 equal 5 ohms, R2 15 ohms and the main current in the circuit is 2 amperes. Now to find the main voltage I need to find the equivalent resistor R equivalent and I main. Now I have I main which is 2 amperes. So I still need to find the equivalent resistance, and once I find the equivalent resistance, I place them in the Ohm's law. Sorry. So Ohm's law states that UPN, which is the main voltage, is equal to R equivalent times the main current. Now to find R equivalent, R1 and R2 are in series. So R equivalent is equal to R1 plus R2 equals to 5 plus 15 ohms. So R equivalent equal to 20 ohms. Now since I have R equivalent and I have the main current, I can calculate the main voltage. So UPN equal to R equivalent times I main equal to 20 times I main, which is 2 amperes. So UPN equals to 40 volts. Okay. Now for number 2, I have UPN equal 12 volts, R1 and R2 equal to 16 ohms, 8 ohms, R2 equal 8 ohms, and I need to find I main. So according to Ohm's law, UPN equals to R equivalent, U equal R times I. In this case, U main equal R equivalent times I main. So UPN, I have UPN equal 12 and I need to find I main. So I need to find the equivalent resistance R equivalent. Now R1 and R2 are in parallel. So in order to find R equivalent, 1 over R equivalent equals to 1 over R1 plus 1 over R2. So 1 over R equivalent equals to 1 over 8 plus 1 over 8 equals to 2 over 8. Now 1 over R equivalent equal to 2 over 8. So R equivalent equals to 8 over 2 equals to 4 ohms. Now I replace in Ohm's law UPN equals to R equivalent times I main. UPN is 12 volts, R equivalent 4 times I main. Now 4 I main equal 12, I main equals 12 over 4 equal to 3 amperes. Okay guys, now I'm going to continue the chapter. We're going to explain a new idea called current voltage characteristic. The current voltage characteristic means the variation of the current with respect to the voltage. Meaning, if I have a circuit that I have a battery, ammeter to measure the current, a resistor, and voltmeter to measure the voltage of the resistor. As a reminder, as we can see in the circuit, the ammeter is connected in series with the resistor and the voltmeter is connected in parallel. Now, this battery here, I have a battery with an arrow. Battery has and an arrow, meaning it is a battery that I can change its voltage, and meaning the voltage is not constant, so I can change the voltage of the battery. So I can make it 5 volts, 10 volts, 12 volts, 13 volts, as I want. So this is a battery with a variable voltage. So I can change the voltage of this battery. It's not a battery of constant voltage. It's a battery with an arrow, symbol. Now, of course, when I change the voltage of the battery, the current in the circuit will change. When I change the voltage, the current will change. Now, the ammeter will measure the current that will pass through the resistor, and the voltmeter will measure the voltage of the resistor as I change the voltage of the battery. Now I have a table here. This table shows the current and the voltage. When the current equals to 1 amperes, the voltage equal to 5 volts. When I change the voltage to 10 volts, the current in the circuit now becomes 2 amperes, according to the ammeter and the voltmeter. If I change the voltage to 15, according to the table, the current becomes 3 amperes. Now, this is the table. Now, if I want to draw the current voltage characteristic, so I need to draw a graph that have the current and the voltage. Meaning, let's take the table. So, I draw a graph. On the x-axis, on the horizontal, I place the current, and on the y-axis, I place the voltage. Okay, always on the x-axis, the current, and on the y-axis, the voltage. Now, I plot each point. So first, let's take the graph. So, I take a scale, current 1, 2, 3, 4, 5, 6, 7, 8. Now for the voltage, I take a scale of 5s for the voltage. It's easier. 5. So 1 square is 5, 15, 20, 25, 30, etc. Now I want to plot each point. So if the current is 1, the voltage is 5. So 1, 5. So this is my first point. Second point, 2, 10. 2, 10. So this is my second point. 3, 15. 3, 15. So this is the point plot. 4, 20. 4, 20. This is 420. And 5, 25. This is my point. Now, if I draw the graph, if I draw the points, if I join the points, I get a straight line that passes through O. So, straight line that passes through O. If I have a straight line that passes through O, it means that this graph belongs to a resistor. So, always, if I plot the voltage current characteristic of a resistor, I will get a straight line that passes through O. So, this is the voltage, the current. Now, as I can see in the table, U over I is always constant, meaning 5 over 1 equals 5, 10 over 2 equals 5, 15 over 3 equal 5, 20 divided by 4, 5, 25 divided by 5, 5. So, the ratio U over I is always constant. Now, this ratio, U over I, is equal to the resistance of the resistor. Now, so if I take any point and I divide U over I get the resistance, meaning If I want to find R is equal to U over I take any point. Let's take 10 over 2. Let's take this point. Voltage 10, current 2, equal to 5 ohms. So R, the resistance of this resistor, is equal to 5 ohms. Okay, now guys, so the current voltage characteristic of a resistor is a straight line passing through O, and R is equal to U over I. The resistance is equal to U over I. I take any point and I divide U over I, it gives me the resistance. Now, which graph of these three graphs represent the UI characteristic of a resistor? Number 1, in the graph 1, I have a straight line, but it's not passing through the origin, so number 1, it's not a resistor. In number 2, it is passing through O, but the graph is not a straight line, so number 2 is not a resistor. Now, in graph 3, it is a straight line that passes through O, so 3 represents a resistor, since it is a straight line that passes through O, through the origin. Now, this is our lesson for today. We'll continue our chapter next lesson. For then, stay safe and good luck.